So here guys, this is a question from the CF round 888, and the question is Vlad and mountains. Here the time limit put test is 5 seconds. So you can safely perform 5 into 10 to the power 8 operation put test case. Can we say that? Yeah. And the memory limit put test is 256 MB. Okay. Now the question is, Vlad decided to go on a trip to mountains. Alright. So he plans to move between n mountains, and some of which are connected by roads. It means it's somewhere like a network, right? Because we are using a connection here, right? And the ith mountain has a height of hi. Okay. Now, if there is a road, means there is a connection between mountain I and Z, Vlad can move from mountain I to mountain Z by spending Hj minus Hi unit of energy. Okay, and if his energy drops below zero during the transition, he will not able to move from mountain I to mountain Z. And note that Sj minus Si can be negative, and then the energy will be restored. Okay, so basically it is telling that at any moment, if Sj minus Si becoming 0 or basically lesser than 0, then I need to provide energy from outside, then only it will able to move from mountain I to mountain Z, because energy total cannot drop below 0 during any transition. Okay. Now Vlad wants to consider different route option, so he asked us to answer the following queries. Is it possible to construct some route starting at mountain A and ending at mountain B, given that initially he has E unit of energy? Okay, so basically I need to tell that, is it possible that I will move from mountain A to mountain B, provided I have E energy initially by outside, you can say. Yeah. So what is the input format here? The input format is like the number of test cases first, and in each test case you have given with n and m. That is your number of mountains and number of rows between them. And look at the constraint, that is of the order of 10 is to power 5. Okay. The second line is your basically the height array, height of mountains. The next line is containing two integers u and v, that is number of mountains connected by road, and it is guaranteed that no road appeared twice. It is basically telling that what is the basically road connecting two mountains, that detail of that is there, because look at the range, that is 1 to n, and mountains is in the order of 1 to n, like total n mountain we have. So it is basically telling about that which mountain is actually connecting. Okay, and look at this part. Next line will consider integer q, that is your number of queries. Okay, and the following queue line contains three numbers ABE. AB lies between 1 to n, initial and final mountain of root. So obviously we get the range as 1 to n, and energy. And look at the energy, this is positive. So can we say that we are always supplying energy from outside? Yeah, some amount of energy that we can say supplied from outside, because it's always positive. Okay, and it is guaranteed the sum of n over all this case does not exceed 2 into 10 to the power 5, and same will go for m and q. And output format is simply, for each query I need to answer yes if Vlad can construct a route from mountain A to mountain B, and else the answer would be simply no. Okay, and this is any case will be valid. Fine. So if I come to the logic part here, then what you can think of is that basically the situation that, let's say this is a mountain I, okay, and this is a mountain Z, okay, right, and I want to move from mountain I to mountain Z. So clearly here the height of mountain I is lesser than height of mountain Z. So I need to supply energy from outside. Then only I can say that I will able to move from I to Z. Can I say that? Yeah. So for that, since given situation is that total energy is always greater than equal to 0, so can we say what constraint we are follow? We can say that Si plus Sj, or not basically Si plus Sj, Hi minus Sj, that is actually going to be negative. So I need to supply a positive energy, right? From outside, and this should be greater than equal to 0. Yeah, this will be greater than equal to 0. So what constraint I'm getting on a height of the mountain side? That is, Hj should always be lesser than equal to Hi plus E. Yeah. So the situation is that the height of mountain side should need to be always lesser than equal to Si plus E, then only I will able to move from the mountain I to mountain Z. So this is our first conclusion. Can we say that? Yeah. This is our first conclusion that Hj should be lesser than equal to Si plus E. Right. Fine. Up to here is fine, but the biggest trouble here is the constraint. This is not the biggest trouble. The constraint is the biggest trouble here. Okay, as we already told that I have to have like any sort of 10 is to the power 5. So if I give it as n into e, then it will not work. But if I give it as n plus e, then also it will be fine. Like n plus e will be fine. But look at it. I have q queries here. So for each query, if you go for n plus e into q, and the queries, if you look at the queries is coming out as like order of 10 is the power 5, and n plus e is also of the order of 10 is the power 5. So this is not going to work again. So this is not a possible available time complexity. So the only possible thing I can think of is that I need to answer in somewhere uh, uh, what we can say like O of n plus e and somewhere like into 1. Yeah. So for each queries, basically I need to perform one operation. Like in the basically of O of 1 I need to answer, right? Exactly. So therefore, if I go by BFS here for each node to find yeah, basically to check like is it possible or not from move from a basically P you can say to Q, is it possible or not? Then it will be give you TLE. Why? Because I need to construct for each query, and you are like first you will check for each node and then you're going to answer. So it is firstly rejected. The most viable option will be going to reject it. Okay. Yeah, because it's going to violate. You have to check like if you use BFS event here, it is going to be O of B plus E into Q. And that is not going to be our possible answer, right? Because look at the order. We already say that this is of the order of 10 is the power 5. This is of order of 10 is the power 5. No, it cannot be a viable one. Now, let's come to the DSU here, as we are looking also that DSU could be a one viable option, but if I just use standard DSU, uh, then like you might say that okay, let's make them in one group, right? Yeah, and then we'll able to say that if the both able to belong to same group, then I can say that I will able to say I will able to move from one node to another. Basically, if both the node, let's say V and E, belong to same group, then I can say that they are connected So yeah, I will able to move from V to E basically. Okay. But the point again remains same, like if I able for Q queries, I need to perform separate DSU operation, and to assign that why I need to perform separate DSU operation, you need to understand that because for each DSU the height is different. Okay, like for each query basically the height given is different, basically the limit of the height is different. So since the height limit is different, I need to construct every time different DSU. So overall I'm getting somewhere again like O of you can say is your V into like somewhere Q, right? So that's why this is also rejected. So what idea I left out? Like the DSU is not working, the BFS is not working. So we got one idea that cannot even use the standard DSU. So what I use here, this is the version of DSU or a special version of DSU when we need to answer certain queries, right? Like what I say that if I need to answer a certain queries, then I will use something called offline. Let me write it here. That's very clearly. That's called offline sweepline DSU. Okay, offline sweepline DSU. So what I did here, guys, here we first going to sort the assets by basically your as width. Okay, yeah, and then we'll process the query and we'll sort the query by the limit. Okay, basically what is the as limit here, what is basically the distance limit here. Okay, so that is the second thing here we do. So what, because of doing that, what is the twist now, like what, why this makes our job easier? Because I have sorted the basically as is by the limit, basically as is by their what do you call weight limit, and the queries by their limit of the like what is the maximum distance query, or basically a node to move from a node to another node it will take, right? So because of these two things, what I can say that uh, as we process over the queries, I am only like I am only supposed to move at a certain range, right? And that range is always sorted, okay? Right. Yeah. Because let's say that in first, like if I sort the queries by limit, then the query one have limit one, let's say L1. That is obviously going to be lesser than query two limit L2. Can I say that? Exactly. Similarly, this is going to be lesser than the query 3 limit. Can you say that L3? Exactly. So what is the point, guys? I am not like here supposed to like I am not need to make a DSU let's say every single time, right? If I make even a one single DSU, my job will be done. Why? Because what I say here, it is at a operating at a certain limit, right? Yeah. So what I did, guys, I think that okay, that let's what we did is that let's group the elements, right, that going to satisfy a condition. So when I process over a query, whatever the elements that satisfy, that going to satisfy our constraint, like our limit, I will make them in one group, right? Then again I process next query. I iterate over all the images. Whatever the one that satisfied, that gets added in this group only. So my task is now very simple. I will iterate again over next query. Whatever the elements that satisfy, that again getting added in one group. So because of that one DSU, I will able to handle. I need to only handle the and I need to check now that whether I will able to move from U to V. So my thing is really simple. Since I just need to check whether this U and V is lying in this group. Okay, because this group is the one that's satisfying the query limit or whatever the constraint here, right? Yeah, basically that it is a S that is satisfying the query limit here. Okay, so only this groups as is, or you can say basically only this group's roads is going to connect the mountain. So if the basically what you can say the root element of both U and V is going to be same, then can we say that U and V is going to be connected, so basically they belong to same group. So this is the concept here, that I'm going to use Offline Sweepline DSU, and what I'm going to do that I will first basically here sort by the like whatever the limit as we sort by the distance, and queries will sort by the limit. And the best part of that is that because of that I'm not supposed to create multiple DSU. One DSU my job will be done, because we are not operating on entire range, we are operating only on feasible range. And by just grouping the elements every time we're moving over a query, we will able to like basically answer whether they move, like whether they are whether they lie in the same group or not, simply by checking the parent. And in this way I will able to answer all the query. Simple guys. Now let's come to the code part of it. Okay, fine, so let's take a template. 1 second. Fine. Yeah, fine. First we take the input. So this is your number of like what is saying n and m is given. Basically n and m is your number of mountains and number of roads between them, and the next thing is your height of mountains. Fine, so let's declare it. And there are n mountains, so that's why let's take the input. Fine, for height part is also fine. Now the next timeline contains two integer u and b. This is the description of the roads connecting basically your mountains. So mountains is like a nodes and roads is like a SS. And here I need to keep track of weight of that also. That's the point, right? So let's first declare SS description. So one is description is that it should be like it will tell the what is u, where it starts, where it goes, and what is the weight it is taking. Okay, guys. So I'm just taking the input for s. Right. Let's say easy. And can I say that I have a m as guys? Exactly. As telling that we have a, you can see that m is the number of roads between them, so I can say that I have a m as is here that is going to join the mountains. Fine. Yeah, now so I iterate and I'll take the input of s's. So what you look for is that I have a u and v that I already take. Now the biggest part is that what is the weight here. Now the point is that what is the weight here. So guys, do you want to understand what is the weight here? Look at this. As I move from this mountain A to mountain B, I always need energy equal to, let's say, energy of this, that is your HB, and this is SA. I need to provide certain energy from outside, and if I able to do that, it should be equal to HB, right? So can I say that the minimum weight limit or minimum height basically I need to travel, or basically the weight should be, is basically the maximum height between both the nodes? Can I say that? Yeah. because this will always going to hold true whatever will be the condition. So that's why I will keep the here weight as maximum of HU and HB. Fine, so that it will able to like survive. That this is the amount of energy it will need. If that amount of energy is not there, then it will not able to reach. So basically it created a clear constraint that this is the maximum amount of height you need to travel, else you'll get out, like you'll not able to reach there, right? So basically now just initializing the S for it. So this is your UV and weight, right? Now guys, there is a next thing is there. If I go for input set, so it's telling that queries, number of queries here we look for. And then the ABE, basically where it started and where it's going, and the amount of energy supplied from outside, okay? So basically the number of queries. Now guys, like to tell you one thing, that for each query, if I take the queries this definition here, then I have a U where it's going, like where it's starting and where it's going, and what is the like what do you say? It's given, right? One thing, that T is your energy supplied. Where it is? Yeah, E, energy supplied from outside. Okay, and so basically let's not write it as energy supplied for outside, let's write it as limit. And we already considered that list limit should must be greater than basically limit on what height of SJ we told, that should must be basically here height of HB, that should must be like uh basically basically lesser than HU plus you can say E, right? Yeah, if limit is lesser than that, then only you're able to cross the barrier to of the energy to move from U to B, right? And apart from this, guys, I will like to keep track of index or whatever the index at which this query actually lies, like whatever the query index in general given. Okay, yeah, basically because what I tell that I will not process the query in the order it given. Basically, when we actually solve it, I process in the random order because we sort the query. Okay, in the random order. That's why. Okay. So that's why since I sorted the query in random order, their index is actually gets hampered. Therefore, I'll keep track of index of them so that when I finally answer, I our index position is actually referred to the whatever the query given initially as an index. Okay. So let's process the query, guys. Here, so vector query. Let's say Q read, right? Total we have q queries for that. Okay, now iterating and taking the input of all q queries. So we have here u v, so we'll take that. Okay, now guys, we already told that whatever the limit is, basically your hu and plus e, uh you will also take the e here. Yeah, so if I initialize a proper query here, then the query basically I is basically your u, v, limit, and the index I, right, guys? So I have actually taken whatever the input needed in the required format. Now my job is to construct the DSU. So let's construct the DSU in general. Okay, for the n elements, right? So let's just write the DSU, guys. I'm just writing my template I already covered in earlier videos. So you can skip it or you can like just move on. I'm just writing the DSU here, okay? Yeah, or I will just forward it in the video. Like I'll just make it fast, okay? Yeah. So, okay guys, just writing the DSU. So since our DSU is get constructed, one more thing, just like let's making the input, since I written the DSU 0 best, so I should take the input also 0 best. That's why I'm just making the input as 0 best. Yeah, fine. Now my work is that I will just proceed with the step of offline Sweepline DSU. So what I first told that I will sort the edges according to the weight. So just sort it. Okay. Edges. Sorry. Exactly. We'll take the edge here. A as B. Right. Uh, I'll sort in ascending order based on the weight. Right. Fine. This is done. Now next thing is that I will sort the query based on the limits. Right. So we'll just going with same thing here. Using the similar lambda function here. Right. Here we have query. 1 second. This is your query. This is A, let's say. Let's say this is query B. Fine. Now I will sort them based on the limits, so that I already told you I did not need to create multiple DSU because of the multiple height limits, and therefore because I will operate in a limited starting range to a certain range, therefore I don't need to create multiple DSU. My work is done with the single DSU only. So that's why E dot limit is lesser than P dot limit here. Can we say that? Exactly, guys. Exactly. That is the point. Let's write it as offset. This should be short, right? Yeah. So my work as per the fourth step of the like offline Sweepline DSU is done for sorting, right? The next step of offline Sweepline algorithm is just basically perform the Sweepline. So how can I do perform the Sweepline? Before that, basically it is utilized to keep the answer of each query. Okay, when we proceed with all the queries, I will keep the answer, whatever the answer we get, whether it is possible to reach from U to V or not. So for keep track of that, since I have a few queries, I'll use a container that will basically keep track of the boolean that is true or false. Basically not true or false, you can say yes and no in one sense, that whether it is possible to reach from one node U to B or not, right? Yeah. So basically performing the sweep line, for that iterating over all the queries. So first condition is that uh, let's take your, what do you say, I will iterate over all the indices. Can we say that? So for that, like because we know in the sweep line, I'm moving every element just one time, right? So can I say that current index is basically your zero? I'm iterating with the zeroth element, because we know that as we are grouping the element in DSU, we are not creating multiple DSU. We are just creating a single DSU. Therefore, we are moving from every element just one time. So I do not need to like reinitialize the current ID. I'll just keep track of this, and I'll just make sure that the current ID should not cross the total number of edges, because I have like basically m you can say rows, so it should not be greater than them, so that our limit should not cross of m as I will safely like say that I have like moved to m as only. And the second condition is that basically if this is this second condition, what we are checking that whatever the cost of your current this is, so as we can say that what is the cost of it? You can say that current ID basically dot weight exactly. So whatever this cost, this should be lesser, right? This would must be lesser than the limit. And what is the limit here, guys? That is your query I dot limit. Can we say that? If this is the case, guys, then what I can think of that, if this is a case, then I can say that I can safely say that I will able to merge the U and V, right? Yeah. So we'll just call the DSU to put it in the same group. So we'll put as current ID dot U and same thing here as current ID dot V. Just unite them in the same group. Right, fine. And I will like to move on to the next element. So just increment the current index of the element. Right, fine. So, and the one thing, guys, that I need to check whether I able to reach from U to V or not in the query one. Whether I able to reach in the queries U and V to not. So for that, I'll check that whatever the element U and V is given in query, whether they're lying in the group we created or not. If yes, then I'll say that the answer is yes. So I'll mark it as true, right? So if what do you say that object dot find the query element we are looking for. So query I dot U if equal to object dot find means their parent element if is same means they lie in the same group, guys. So I'll just mark the answer I equal to true because there exists the you can say that the road that you can move from U to V, right? They are connected, they are in the same component, so obviously there is existence of the road connectivity, right? Else I'll just mark the answer I as false, right? Fine. So similarly, we will able to get all the answers. So my work is done. I will basically get the answer of all the queries. Obviously, guys, there is a mistake. This mistake we don't do because the index of queries is not the same. They are as given initially. So I'll just write it as query I dot I. That is the actual index because we have sorted the queries, so we change their positions. Therefore, we are since storing the answer based on the given actual index, so we'll write the actual index. That's why we have keep track the index initially. Okay, yeah. Now I get the answer for all the queries. So just iterating over the queries, we have Q. If answer I is basically what do you say? True, then we'll say that yes, print yes, sorry, else print no, right? Exactly. Uh, can you get that? Yeah, look at this. Yes, no, yes, yes, no. There's an handle, guys. Yeah, keep track of the output format, okay? Yeah. Yes, no, yes, yes, no, yes, no. This was just the case sensitive. That's why it's giving the wrong answer. So overall, it's a correct answer only. If I just pass to CF, then also we'll get like it's coming correct only. Just verify it. Okay. So here, I have submitted it earlier. Like, let's resubmit it. Okay, just to verify. Yeah, let's see. What is happening? Like, it's taking a lot of time. Yeah, running. Right, right, right. Come on, come on. Uh, oh, fine, fine, accepted. Yeah. So that's it, guys. This is the solution for the question. Thank you.